Hi friends, welcome back. We're talking today Saxon Algebra 1, 3rd edition. That's that orange book. Lesson 71, trinomials with common factors, and we're talking about subscripted variables. All right, let's get right into it. Factor this guy. All right, what we're doing is we are looking at this to see if any of our chunks have a common denominator, and they sure do. We have, let's take out from each of these chunks, I can take out an x. So I get x, and that leaves me with x squared plus 6x plus 5. Now, this trinomial here, I can also factor. We go x, and then we're going to split this up like this. We're going to put x in the front, x in the back. This tells me, because it's positive, same signs, this tells me positive, positive. So plus and plus. Factors of 5 are just 1 and 5. I need a positive 1 and a positive 5. That'll give me positive 6. So kablam, I have just factored that trinomial that has a common factor in front of it. All right, let's look at this guy. We have factored this one out. So it looks like they have a 4 and a b and an x in common. So I'm going to take out a 4bx, and that leaves me with x squared minus x, and then minus 20. All right, so I have 4bx, x squared minus x minus 20. So let me rewrite that down here, 4bx. I'm gonna factor this like this. We do our bubbles, x, x. Look at the last sign, that tells me different signs. So I'm gonna do plus and minus. Factors of 20, 1 and 20, 2 and 10, 4 and 5, woo! I need a positive and a negative that gives me a negative 1. Well, if I do positive 4 and negative 5, that'll give me negative 1. So positive 4, negative 5, and there we go. We have completely factored this. All right, 2 more examples here. Looking at this, if you ever have a negative in the front of your polynomial, get rid of that guy. We're going to factor out a negative 1, which leaves me with x squared minus x minus 20. Now I have negative 1, and then I'm going to do this right here. I have x and x. This tells me different signs, so plus and minus. Again, factors of 20 here. Looks like 4, I need a positive and a negative that gives me negative 1. So if I do positive 4, negative 5, that will added together will give me that negative 1 here. So there's our solution. I wrote a negative 1 in the front here. Typically you don't. You want to write it like this. But if you need to put that 1 there, that's totally fine. So there you go. That's how it should look. All right, let's look at this one. Looks like they have an x in common, and they also have a 3 in common and a negative. Get rid of that negative. Remember I said that? Notice when I got rid of that negative, by the way, it changed all my signs. That's because if I factored a negative into here, I would get negative. To here, I would get positive, and a negative to here if I distribute it back out. So negative 3x, and that leaves me with x squared plus 2x minus, because a negative times a negative would be a positive, and 72 divided by 3 is 24. So minus 24. Okay, so I have negative 3x, and then I've got this, x, x. This tells me different signs, so plus and minus. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. My old golden retriever is standing right here wanting to be fed, so I apologize. You can probably hear him in the background. I need a positive and a negative that gives me positive 2. Well, if I do negative 4 and positive 6, that'll give me positive 2. So positive 6, negative 4, we have just completely factored that guy. Okay, so let's take a look at some subscripted variables here. Subscripted variables. So would we want to solve this by elimination? Now, eliminating variables, pause 1 second. Sorry about the pause there. For elimination, we've got subscripted variables here. All that means is it's just a fancy way of saying, hey, there's a couple of n's in this problem. This n refers to n, this n refers to d. Typically it's nickels and dimes when you see these problems, so just keep that in mind. All right, so I just took my dogs out. Now I've got dog hair everywhere. Okay, elimination. We can either eliminate nn or nd. I think nn is going to be the easiest. Opposite of positive 5 is negative 5. So in order to get a negative 5 down here, I'm going to need to multiply everything by negative 5. Let me rewrite this. 5nn plus 10n d equals 125. That's just the top one. Now I'm going to take this negative 5 and distribute it to all 3 chunks here. So if I've got negative 5nn minus 5nd equals negative 80. In my head, what I did is 16 times 5, cut this in half, 8, double this, get 10. 8 times 10 is 80. So that's just some way of thinking about mental math. All right, we're adding these together. 5 and negative 5, those eliminate out. That's why it's called elimination. Positive 10, negative 5 gives us positive 5nd equals 20 to 100, 20 and 25, 45. So we get 45, positive 45 here. To get nd by itself, we're going to divide both sides by 5. And we get nd equals 9. Okay, now that I have that, I can plug it into either the top or the bottom equation. You can even do the revised equation here if you wanted to, but I'm going to do this bottom equation here and say nn plus nd equals 16. nd equals 9, so nn plus 9 equals 16. Minus 9, I get n equals 7. So our answers are nd equals 9 and n equals 7. So the deal with subscripted variables is it's just like a regular variable. It's just another differentiating way of saying, hey, this is what variable it is. All right, so this one is asking us for substitution. When I do substitution, I like to write them side by side. So 5nn plus 25nq equals 290, and then nq equals nn plus 2. Again, this is saying like the number of quarters equals the number of nickels plus 2. That's typically what we use these for, but you may see it different. Now, looking over here, I look at that and I see 5 goes into all of those. Man, make your life easier. Let's divide every single chunk by 5. We're allowed to do that as long as we do all of the chunks like that. So if we've got 290 divided by 5, that's going to give us 58. Okay, so now we know that NQ here equals all this garbage. So we're going to take that garbage and we're going to insert it right over here for this NQ. And you can see how that making these numbers smaller made it a little bit easier on us. So we say NN plus 5 times NN plus 2 equals 58. NN plus 5, NN plus 10 equals 58. Minus 10 from both sides. And at the same time, I'm going to combine my like terms here to get 6NN equals 48. Divide both sides by 6. I get NN equals 6 times 8 is 48. So NN equals 8. Now that I know this information, I can take it and plug it in right up here. I already know NN is 8. So NQ equals 8 plus 2. NQ equals 10. And there are your answers. Okay, so let's try these practice problems. So on these ones, here are your practice problems. Try those. Pause the video, try those, come on back. All right, so for this guy, we're going to take out, here are your answers for those. If you did not get this, then stick around and I'll show you why. All right, so if we do, it looks like I can take an x and a negative, and remember there's a negative in the front, so take a negative out. So negative 4x leaves me with x squared plus, because I'm changing my signs, 7x plus 12. There we go. I had to think about that one. Woof. So we have negative 4x, and then let's factor this, x. This tells me same signs. This tells me positive, positive. Factors of 12, 1 times 12, 2 times 6, 3 times 4. I need a positive, positive that gives me positive 7 when added together. Positive 3, positive 4 added together gives me positive 7. So this right here is my factored version. Looking at this, I see a negative in the front. I also see that it's out of order. So let's fix that. We're going to say negative x squared plus 2x plus 24. You always have to fix it. Take a negative out, and that leaves us with x squared minus 2x minus 24. Let's not forget to bring down that negative. X. This tells me different signs. So plus minus, 1 times 24, 2 times 12, 3 times 8, 4 times 6. My goodness, not knowing my multiplication here. I need a positive and a negative that gives me negative 2. Well, if I do positive 4, negative 6, that will give me my -2. So +4, -6. Okay, so just double checking as I go along, make sure I get the right answers. Hate having to redo videos because I messed up. So there we go. Substitution, we are going to do this. Substitution again means side by side. So let's write these guys side by side. This is another case where you don't have to do this extra step, but it looks like 6 goes into all of those. So let's divide everything by 6. I haven't even written my other one yet. Hold on. Let's write that. Equals nn plus 5. So that gives me nn plus 4nq equals 60. Now, nq equals all this garbage here. So I'm going to take that, and it helps to draw the arrow so you know you're putting it into the right one, because I see kids often put it into the wrong information. So we've got nn plus 4 times nn plus 5 equals 60. So nn plus 4nn plus 5 equals 60. I'm going to minus 5 from both sides, and at the same time, I'm going to combine these. So we're going to move this up over here. So n1 and n and 4nn gives me 5nn. These canceled out. 60 minus 5 gives me 55. Divide both sides by 5. nn equals 11. And now that I know that information, I can plug that back in over here. So nq equals nn, which we know is 11, plus 5. So nq equals 16 there. All right. Oh, I got 8 and 13. What did I do wrong for C here? Okay, I'm going to pause this video for just a second. You guys, you didn't catch me doing this way back over here. Okay, so pause one more time. All right, you guys, look at back here. I distributed that 4 to n, and then I forgot to distribute it to the 5. That should be a 20 right there, which makes all the rest of this garbage. So let's redo it by looking like this. Okay, so here is what it should have looked like with that 20. So minus 20 minus 20, that gives me 5nn equals 40. Divide by 5, divide by 5, nn equals 8. Take that information, plug that back into here. 8 plus 5, so that's nq equals 13. So there's my 8 and my 13. I'm so sorry about that. If I knew how to edit videos, I would edit that part out, but you're just gonna have to suffer with me. Okay, so the next one is elimination. So we can eliminate either the nn or the nd. I think nn is gonna be the easiest. Opposite of +6 is -6. So I'm gonna need to multiply this by -6 to get a -6 there. So when I do that, I'm gonna rewrite everything over here. 6nn plus 12nd equals 180. -6nn minus 6nd equals, now I'm worried that I'm gonna mess up. 12 times 6 is 72, right? Okay, yeah, -72. So in this case, our nn's cancel out and we're left with 6nd equals, let me make sure I got this right, -72, yep, 108. Okay, divide by 6, and we get nd equals 18. 18, is that what we have? Yeah, nd equals 18. Whew! Okay, there's nd equals 18. Now we can take it and plug it into either the top or the bottom, doesn't matter. I'm going to use that bottom one, nn plus nd equals 12. You can even make your life easier. We're solving for n. We already have nd, so we need nn, so we can minus nd from both sides. You can do it this way if you want, or you can just plug that number in. nn equals 12 minus nd. We now know that 12, or nd is 18, so we get 12 minus 18, which means nn equals -6. Is that what we got? We did. Excellent work. Sorry about that. If you have any questions, leave them below. Otherwise, great work, and we'll see you next time.